No.
Yeah, there's
Stop that!
I wonder what there's a lot of strings in
That's
it.
without reason.
It is not even!
Yes, it is. This is the
No,
time.
he wants to
Do you want her to start?
Alright. Alright, I have this guy here. Now,
That's why.
this is a fan mounted on a cart.
Wow.
No way.
Loud fan. Bro,
It's kinda
small and loud.
Now, because it's a fan mounted on a cart, we give it the very original name called a fan cart. Okay? So, if I turn this on,
Like one of those alligator time. Whoa. Let it keep going. Does it fly? Does it fly?
not in a good way. Alright, have you seen something like this before? What kind of, where have you seen it? Maybe not maybe you've never seen it in person. Go ahead. So there's a hovercraft, so it has fans underneath that kind of push it up, and then they put a fan on the back that somehow pushes it forward.
The one you see alligators in?
Good, so it's called it's a fan boat, right? Isn't that what they call it? A fan boat? Right? It floats on the water, there's a huge fan on the back, and it somehow makes the boat go forward. You've seen this thing before, yes? Okay, so, well, it just is, man. Here we go. So if I let this go, which way is it going to go?
That way.
And fly.
So, would you say,
Doesn't produce enough
Is
light.
it gonna like take
Why?
off and soar around the earth?
no, it's literally going to fall on the ground and break.
Oh, you know what skill I really
Let's
want to
prove
do?
it.
I want to be able to fly with an umbrella like Mary Poppins. Like
Thank you, Lily.
I want to become a bird.
I'm gonna say, don't try it, man.
when I was
Don't try it.
in elementary school, I would take like a Kroger bag.
Paragliding was a real
And I'd
thing.
like jump off of the ledge, like
I would take a Kroger bag.
That's yeah, just like this. Just like this.
Okay, let's reset. So, here's the real question. If I let this go like this, I'm just going to let it go.
I know, me too.
I'm just going to let it go. Does it have velocity?
Yes.
When I let it go?
No.
No, it doesn't. Does it start very soon after?
Yes.
Yes. Is it accelerating?
Yes.
What direction?
That way.
It's accelerating this way. Right? Okay, so here's the deal. So we saw that. Now, if I start in the middle of the track and I give it a little push, where is it going to go? I'm going to push it that way.
it's gonna go that way for a little bit and then go back.
That way, man.
It's going to go this way
It's moving.
and then come back.
Yes. It's a magical bar.
Whoa. That's
Okay? You all see that?
I feel the wind. Why? I feel the wind from it. Yeah.
Okay. Y'all good there?
Yeah.
Y'all see what happened?
Yes, sir.
All right. So let's see if we can't. Don't do it. Let's see if we can't diagram this up real fast. So what I have here.
Like, why is it an expression?
No, you can just watch. It's all right.
What was your Halloween with your kids?
But like people say,
What were your kids for Halloween?
let's see if we can do this.
You guys should have been the Ghostbusters.
Society.
That's a pretty drawing.
I'm a big fan of that.
I'm a big fan. That's just a picture of the
All right. Now, here's the deal. Let me tell you the rule. Okay? So when I turn this on, after I let it go, it slows to a stop and then speeds up in this direction. True?
I what?
Go buy it.
What we saw was that it's accelerating this direction.
Correct.
True?
Yeah.
Even when it was moving this way, it's still accelerating this way. Is that cool?
Uh-huh.
We'll see how that manifests here in a second. But I want to tell you the rules so that we can understand it. The fan blows the air that way, therefore it accelerates the other way. The acceleration of the car is always opposite the direction that the fan is blowing the air. Okay? Does that make sense?
Yeah.
Okay? The acceleration is always the opposite direction as the fan is blowing the air. All right, so here we go. Starting the car here. We're going to have to draw a position graph. Where's the car at time 0?
It's like halfway.
Halfway, that's right, in the middle. I like it. All right, so what I'm going to ask you to do is put your finger in the air. I'm going to say 3, 2, 1, go, and you're going to draw what you think the graph looks like, the position graph.
Where it looks like.
Wait,
Which side's 0?
which way is 0?
So in here, just for simplicity, we always put the position 0 there.
Wait, no, but
We are looking at it after I push it, it's already moving. So the velocity is this way.
Oh, we're going. It's that way.
So I have pushed it. I have pushed it, so let me demonstrate. We're going to start looking at it right after I let it go. So right after I let it go to right before I catch it. All right, yes?
So like
It would go
in real
down
life, is
on that
this side
output.
the 0 or is that side?
Well, you were on the wrong side, they're on the good side.
Oh, okay. Well, I don't know the way it's oriented.
Yes. So they're on the good side, you're on the bad side. But we're going with this picture. Are you ready? Finger in the air. First of all, what shape does it have to have?
Parabola.
Has to be a parabola. Are you ready? Fingers in the air. All right. 3, 2, 1, go.
Oh, I don't know.
I don't know.
I disagree.
Oh, what are you doing,
The
son?
car is time traveling.
What is doing about this? I'm so low.
That's how it weighs. I drew the graph, that's how it weighs.
Yeah.
It's not circle around.
I'm making a graph or is the teacher making a graph? I'm making
Because look.
I say time travel.
Where does it start? Here. Where does it go? Away from the 0. Where does it end up? At the 0.
At the block. Actually, ends up at the
And which?
Because the fan is blowing it back. So even though you push it this way, well, that's why it says.
It looks like a person on the train going like this backwards.
See it.
Looks like a dog that's yelling.
Okay?
Yeah, a dog is like whoop,
How do those dots look?
basically like going backwards.
Those look good?
Yeah.
All right. Now, let's do the velocity. Are you ready? Which way is it moving when we start? To the right or to the left? It's
Right.
moving to the right. What does that tell you?
Accelerating.
Positive.
Velocity.
So, if you're moving to the right, your velocity is positive. Is that cool?
Yeah.
So, what do we notice about its velocity after I let it go? It slows to a stop and then speeds up in the other direction, true?
Yeah.
All right, so get your finger in the air. All right, I'll even give you a hint on this one. It's either up and to the right or down and to the right. Are you ready? We're doing the blocks here. Ready? Up and to the right or down and to the right? 3, 2, 1, go!
What?
I have down and to the right
Does it not go up
because...
and then down?
No.
Yeah.
Oh, we could start spot. Yeah.
Oh.
Idiots.
It's always accelerating.
So, here's the parts that you want to know.
Getting less positive.
The initial velocity is positive. At some point, the velocity is 0. And then, what does this mean here? It means it's, go ahead.
The velocity becomes negative.
Yeah, you see how it drops to negatives now? Which means which way is it going now? The other direction. And it's getting farther from the t-axis, so it's speeding up. Okay? Is that cool? All right, now, the acceleration graph. What do you know about the acceleration graph?
Constant negative.
Is it?
Or
All right, put your fingers in the air.
it's like
I'm going to say 3, 2, 1, go, and I want you to draw. Are you ready? Fingers in the air. Gio, are you with us? Are you sure?
Yes.
All right, fingers in the air, ready? 3, 2, 1, go.
Oh,
What?
they're straight lines.
So this is a moment here. So it's definitely horizontal,
It's the slope of the velocity.
but is it horizontal above the T or horizontal below the T?
Below.
Check your neighbor now.
Below.
Horizontal above the T or horizontal below the
I don't
T?
understand the difference between above and below, and I really want to.
Oh, I think it's above.
I think it might be. It might be.
Below T.
So, time doesn't exist, yeah, so it's probably on the T.
All right, here we go. Above or below? Below. Okay. Now, our definition for acceleration is it's the slope of the velocity graph. If you look at that green line, tell me 2 things you know about its slope.
The slope is negative.
And it's negative and constant. But this is a problem because in the first part of my run, it's slowing down. In the second part of my run, it's speeding up, but my acceleration is always negative. You see why that seems weird?
Yeah.
Okay, but let me show you what I think the arrow should look like. The velocities are positive to start, and then 0, and then is that cool?
Mm-hmm.
How do you think this arrow compares with this one?
In the same direction. Oh wait, no. I thought you were talking about the acceleration.
Oh, well, just these velocity arrows. If I compare this one here and this one here, they're going to have the same length because the speed is the same, but the opposite direction. Okay? What about the acceleration arrows? Is that cool?
Yeah.
You guys okay with that? All right. So what we need to do now is we need to compare this one to this one. So I'm going to switch it around. Okay? So it's here. You roll forward.
What if you were to make it go uphill? Die. That's very problematic.
So,
What if you're doing with it like this?
Uphill.
Would the fan be strong?
if it was going downhill, okay, if you turned on the fan, no, but if you turned on the fan and then put the fan like pushing it downhill, would it go cubically or quartically?
Probably still quadratically. It would be like a very
It would just be, yeah.
Yeah.
I'm glad to see that we are all smart people here, except for you.
No, I said it was. That's disrespectful. I just read it.
My birthday is messy.
It all starts with an N.
My birthday is messy. Like the whole month.
No, it's not. No, I think I missed it. Grace, isn't your mom really in it? No, no. What is it? It's like a baby. Oh, I'm really off.
Yeah, I'm not.
She seems like a baby.
I mean, the weather was probably made to shut born over here.
My goal was to have every single one of the best.
And the weather.
Are you ready? Fingers in the air. Let's do the position graph. Ready? Position graph. 3, 2, 1, go.
Negative parameter. Yeah.
Does it have to touch the zero?
So it depends on how hard you push it. If you push it a little harder, it gets all the way to the 0, but I didn't push it very hard, so it only got to 2.
Yeah.
Cool.
Wow, man.
Is that cool? Let's do the velocity, fingers in the air. Ready? 3, 2, 1, go. So when we look at it, it's moving to the left. So it's going left, which is negative velocity.
What?
What? Yes.
Is that cool?
Yep.
All right, acceleration. Get ready with your fingers. 3, 2, 1, go.
Above the T.
Above or below? Why?
Thank you. Quality.
Velocity times acceleration.
Quality is the acceleration positive.
Right?
So true.
All right. Now, this is all fine and dandy. I feel really good about this. If I put in the velocity arrows, it's moving this way. The accelerations are all pointing which way?
I'm a psychopath. It makes it really hard to line up.
Oh, it is?
Now you have OCD.
Cool? Now, I want to point out a couple surface features here that are going to help you know if you did this right or not. Let's look at the second one here. What do you notice about the acceleration value? Positive or negative? Positive. Positive. And which way do our acceleration arrows point? To the right. On the top one, our acceleration was negative, and which way do all our acceleration arrows point?
To the left.
To the left. If I look at this velocity, it starts out positive and then ends negative, so these arrows start pointing to the right, and now they're pointing to the left. This one starts out negative velocity, ends positive, so these start out to the left and then end to the right. Okay, do you see the surface features and how they show a little bit deeper meaning here? All right. But this is where, for me, the wheels fall off the cart.
How many times do they find?
Literally.
It is every single day.
I know. Well, they fall off the cart. That's it. They fall off the cart, then we reattach them, then they fall off again. But this is for real, like the problem.
Okay.
Okay? What's happening in the first part of this run? I let the car go and it slows to a stop. True?
Yeah.
And then it speeds up after that. Here's my issue. What do I notice about my acceleration down here? Is it negative the whole time?
Yes.
But even when it's speeding up, my acceleration is negative. Does that seem weird to you?
No.
But I mean, in my head, doesn't negative acceleration mean slowing down?
Yeah.
I mean, you see my, here, let's do this one over here.
It's about direction.
When I look at this one, it's slowing down for the first part and then speeding up. But what do you notice about my acceleration value here?
I'm scared to ask.
It's positive the whole time. Even in my first part where it's slowing down, my acceleration is still positive. Do you see why this might be an issue?
Yeah.
See, maybe in 8th grade you were taught like negative acceleration means slowing down.
We didn't learn anything in 8th grade.
I know. We don't need to do any commentary.
I
Yeah.
just want to let you know. I threw watermelons off the roof.
Oh yeah, you were
I
here
wasn't even
with
there for
us.
that, and it's the only thing I remember about that
Oh,
class.
refocus please. When I look at this, does negative acceleration always mean slowing down? No. Does positive acceleration always mean speeding up? No. So we gotta go deeper. Okay? So I'm gonna hint to you that if you look at the value of the acceleration, or the sign of the acceleration and the sign of the velocity, that you may be able to divine some deeper meaning. Ready? These are positive here, these values are negative here. These values are negative here, and these values are positive here. Do you see what I'm talking about? Okay? So, here's what I want to know.
Cross my ankle off the man.
So, tell me about the fan cart. in this first section here, what was it doing? Slowing down or speeding up? It was slowing. And what was the value of the velocity, positive or negative? Positive. And the acceleration? Are you with me on that? Okay. What about the second part of this run? What was it doing? And tell me about the values. Okay? You with me? What about the first part of this run? What was it doing? Slowing down, and what are the values? So the velocity is negative, but the acceleration is positive. And then the second part of this? And, all right. So I've drawn the chart for you. Okay? I've drawn the chart for you. What I want you to do is I want you to look at the chart and I want you to decide, is there a way, if we knew the values of the acceleration and the velocity, that we can somehow glean some deeper meaning here? Check with your neighbor now. See if your neighbor knows.
Whenever they're the same.
Okay?
When they're different. Same time.
Gotta be like so
I promise there's nothing.
And it's just.
He has to have so much willpower.
How are you?
I'll be over there looking at my hand. It's alright. Yeah, they're two composers.
If you're looking for a positive,
That's actually what it is.
positive, negative, which is an interesting foresight, I think, which I think is
Because like when you're gonna watch there's a lot of
Alright.
You're the deep closer.
Would someone like to suggest a rule? Go ahead, Ben. Listening, please.
I really don't know how to explain it, but like, if like slowing down, and you consider that negative, and the velocity is positive, so positive and negative make a negative, and then it give you a negative acceleration. And then if you do a positive acceleration, you get negative and slowing down, which would be two negatives and make a positive.
So he's, what I'm hearing him say is he's kind of relating it to like our multiplication rule, right? If you have positive and negative, you have negative, and if you have negative positive, you still have negative. Is anyone feeling what he's saying here? Grace, what were you going to say?
I was gonna say, like Sarah said, that when the signs are the same, they're speeding up, but when they're different, they're slowing down.
Okay, that's consistent with what you said, right? What were you going to say?
Well, I'm just saying, like, I don't know, but like, it's like two negatives equal positive, and two positives obviously equal positive. Due to the multiplication rules, the slowing down, if you were to multiply them, would always equal a negative, and the speeding up would always equal positive if you were to multiply them.
And Paul, you're on board with that?